In this video, we will discuss DC conditions of an amplifier and how to check the DC conditions. This is the circuit diagram of a single-stage RC coupled amplifier, which consists of an NPN transistor, resistor R1 and R2 to provide voltage divider biasing, resistance Re to stabilize the operating point, resistance Rc is the DC load, capacitors Cc1 and Cc2 are the coupling capacitors to couple the input signal and load respectively. Bypass capacitor Ce is connected to avoid any sort of AC voltage drop across the emitter resistance Re. Any sort of AC voltage drop across the emitter resistance Re results in a reduction in the voltage gain of the amplifier. Now let us discuss about the DC conditions of an amplifier. DC conditions of an amplifier defines the DC voltage drop across various components of the amplifier without applying any AC input voltage. So DC conditions defines voltage drop across collector resistance Rc, emitter resistance Re, voltage drop across resistors R1 and R2, and voltage drop between transistors collector and emitter regions. In other words, VRC, VRE, VCE, VR1 and VR2 defines the DC conditions of a RC coupled amplifier. How to check the DC conditions? Connect the circuit of the RC coupled amplifier as shown without connecting an AC voltage source. As there is no AC input, there is no role for capacitors Cc1, Cc2 and Ce. So we can remove capacitors Cc1, Cc2 and Ce from the circuit. Now as load resistance RL is isolated from the rest of the circuit, we can remove load resistance RL also. So this is the circuit we should consider to check the DC conditions of the RC coupled amplifier. Measure various voltages. First of all, ensure that the circuit is properly powered. Measure VCC. Next step is to measure voltage drop across collector resistance Rc. Voltage drop across collector resistance Rc should be 50% of VCC when there is no input signal. So if VCC is equal to 12 volt, voltage drop across collector resistance Rc should be 6 volt. Measure voltage between transistors collector and emitter regions, and that should be 40% of VCC. So if VCC is equal to 12 volt, VCE must be around 4.8 volt. After this, next step is to measure voltage drop across emitter resistance Re. Voltage drop across emitter resistance Re must be 10% of VCC. So if VCC is equal to 12 volt, voltage drop across resistance Re, VRE, must be approximately 1.2 volt. Next step is to measure voltage drop across resistance R2. If you analyze the loop which consists of resistance R2, transistors base emitter region and emitter resistance Re, we can find that VR2 is equal to VBE plus VRE, application of KVL. Ideally, for a silicon transistor, VBE is equal to 0.7 volt. VRE is ideally 10% of VCC. So VR2 is equal to 0.7 plus 10% of VCC. So if VCC is equal to 12 volt, VR2 should be approximately 1.9 volt. Finally, measure VR1. VR1 is equal to VCC minus VR2. Again, application of KVL. If we consider the loop, which consists of voltage source VCC, resistors R1 and R2, we will find that VCC is equal to VR1 plus VR2. Or we can write VR1 is equal to VCC minus VR2. As VR2 is equal to VBE plus VRE, we can write VR1 is equal to VCC minus VBE plus VRE. In this way, we can ensure that DC conditions are satisfied for the RC coupled amplifier. If DC conditions are established properly, the RC coupled amplifier will amplify AC signal. Thanks for watching Circuits Analytica. Enjoy learning.